Oh, welcome everybody to SolidWorks Live Design, another episode. We love this format because it's our chance to get to hang out with you guys as close to in person as we can. So we see you all in the chat already. Excited to see you here. I'm going to try to get through this intro as fast as I possibly can because today I have Mark Peterson with me, and I know he is just like a racehorse, ready to get out of the gate. Ironically, I saw he showed up with a horse mug, which is funny because I was going to say this anyway. He's got more content to fit in this 20-minute segment that we could possibly fit in. So I'm going to try to get out of the way as quickly as possible and say hello to Mark.
Hey, Jesse, thanks for having me again here for certifications and how to pass them part 2.
Part 2. I was going to say the last time we spoke on this show, we talked about certifications. Here we are again. You're a man of your word. We teased a second episode. We're back for another episode.
Yeah, we kind of left off like halfway through the part section of CSWA. So I thought, we'd try to get through the rest of that and through the assembly portion of it and just kind of, finish everything off. Hopefully we can do that in, about 20 or so minutes. So
excellent. Do you want to give us a quick overview of what we're going to hit today since we are kind of disjointed? We've got a part 1 that we already hit, maybe a quick overview of what we did, then where we're going today.
Cool. Yeah. So, so basically, we're just going to do a review of, the last video that we did together, and then just very quickly go over kind of the same stuff. Again, if you want to review any of that sort of stuff, just head over to that to our YouTube channel. Check out, the previous episode. We go through a lot of the stuff in a lot more detail. So, and then of course, we're going to go through finishing up the rest of the CSWA sample exam, and then. I'll actually be in the news and info community after this. So if you guys want to ask more questions or get in touch with me or get clarification on anything, we'll be there for that.
Yeah, that's a great point. We'll try to get to questions as they come in today. But like Mark said, there'll be a community, solidworks.com/askmark, and we can follow up with you there as well.
Cool. So let's get started. So again, we're on SolidWorks certification, just kind of going over that. And we're just going over some tips and tricks and that sort of thing. And so the first thing we'll kind of start off with is just, a quick, what is the SolidWorks Certification Program? So we have, again, we're on part 2 today, but the certification program is a worldwide industry recognized certification program that's used to benchmark and measure your knowledge and competency in SolidWorks software. We started this in 1998 with the CSWP exam, and today we have 33 certifications, and there's been over 600,000 certified users. Now we have for a lot of our products, we have these sort of certifications at different levels: associate level, professional level, and expert level. And they kind of work on top of each other. You don't have to take the associate level exams to then take the professional ones, but you could. It's a good place to start, and you can go from there. We also have the similar exams for our 3D Experience products, 3D Experience platform, like the Collaborative Industry Innovator and 3D Swimmer and things like that. So let's now quickly jump into why would you take the certification exam, or what is the value, I guess, of taking these exams. So I think for many people, one of the things you think about is how will I, assure my future employer, if I'm trying to get a job, that like I have the skills that they need, in a design engineer, for example. So when you're thinking about getting hired, if you have one of these certification exams, it shows that you have a certain level of competency in the SolidWorks software and in, mechanical design in general. So that's a great reason to take some of these. If you're already employed, it's a great way to demonstrate your willingness to learn more and to achieve more. It's great for your personal development as well, or your professional and personal development. If you're not quite at the point in where you're starting your design career, but you're a student, the certification program is a way for you to validate your skills and prove your skills, as well as just a great way to have an idea about, some of the ways that you can design in SolidWorks faster and more quickly. And so, this is a way for you to kind of really understand, like, how good are you at SolidWorks? Maybe you've learned a lot of the stuff yourself, but from our perspective, from the SolidWorks perspective, how good and how competent are you at the software. And then one of
Yeah,
the things I like is, every year at the 3D Experience World, we have a special event for people that have taken the CSWE exam and have passed that. So, there's other events and stuff that you can get access to if you have taken a certain level of certification.
the real reason we take the exams, right, to get into the parties. But
Oh
I
yeah,
think,
definitely.
I'm sure you'll agree, but and of course, we're biased a little bit, but I think we have one of the best certification programs of any software that I'm aware of, something that we're very proud of. But, but I really love, like, the positioning of them. I think they've done a phenomenal job of trying to figure out, that, like, sweet spot, because sometimes, like, a test is kind of pedantic in some way, like, they try to make it hard for the sake of being hard, but I feel like everyone that I've taken has been right in that good sweet spot of, like, it's hard enough that they're not gimmies, right? You definitely need to know what you're doing, and they're timed, so you've gotta be pretty efficient, but they're a pretty good marker, I think, that people find of, where are my skills? They're a pretty perfect level. I think they've done a really good job with the ones that I've taken, and I think the community responds to that. I think just yesterday I saw Kara Tucker, a friend of the show. She was posting on LinkedIn that she got her CSWP, and just reading through all of the comments of people just cheering for her and excited about it. I think because they have value and people see the value in that, it really adds to the community sense of getting them, and people understand what it is that you've gotten and what you've achieved. So it's really cool
Yeah,
program.
absolutely. And so now that everybody knows that how valuable it is to take this, how do we take it? So it's a really simple process, two-step process here. You really just need to obtain a credit and then install the Tangix Tester Pro software, which is a free software to download. You add that credit to the software, and now you're ready to take the exam. There are a lot of opportunities to get these certification credits. Customers on active subscription could take up to 3 certs 2 times per year. There's a lot of promotions and stuff on our social channels a lot of times, events at 3D Experience World, and that sort of thing. And students a lot of times have access through their school. So if you want more information, go to solidworks.com/certification. You'll get more information there. But it's really very simple. You can just go to this website, download the client, and now you're ready to get started taking the exams. You'll need a virtual tester user ID. Again, those are all free, so not difficult at all. And then you just select the exam that you have the credit for, click on Start Exam, and you're ready to go. So let's talk about passing the exam. So you will want to have, in my opinion, the best way to pass these is to go and get the training courses from our resellers. I think that's the best way to do it. If you take an essentials course, you're going to be pretty much ready to go to take the associate exam, and you may even be ready to take the professional exam after that too, if you really paid attention and did well in our classes. So you can get more information about that at this URL. But there are other places you can go to get more information, like the built-in tutorials, My SolidWorks, Solid Professor, and there's a lot of practice packages that you can download from our website as well. So definitely check out all these resources. Um, but yeah, this would be kind of the stuff you would want to study ahead of time, so you really have an understanding of what you need to do. Okay, finally, some quick keys to success, and then we'll finish off with the last bit of the CSWA exam. So uh, like we talked about last time, for every new part you create, make sure you set your units, material, and save it. Those are the 3 most important steps. Units are important because it's asking you for mass. So if you put in a mass in pounds when they're asking for a mass in grams, it's going to be wrong. Material is important because what you're developing and building in SolidWorks is the volume, but the material gives you the density of the object. So with those 2 things combined, you can get the correct mass. So if you don't have the volume right, you're going to get an incorrect answer. If you don't have the material set properly, you're also going to have an incorrect answer.
Yep.
And you want to be real careful because in some of these exams, they will have an answer that is the correct volume with no material applied. So, and you will pick that choice because you'll see it and you'll say, oh, that's answer B. Like, I'll choose that one. So be very careful about that.
Yep. Yep.
And of course, save and save often because, if something happens to the machine or, closes out or something, you don't want to waste a bunch of time rebuilding a bunch of stuff that you just created. So we also talk about global variables, keeping your sketches and that sort of thing simple, getting familiar with keyboard shortcuts. And if you get stuck on something, feel free to skip that question and move on to something else. So again,
Yeah,
sample
that's
exams are
great
available.
info. Eric was just commenting in there that everybody should screenshot that and bring it with them. Yes, tape it to their monitor the next time they take an exam. It is good because a lot of those things are easy to forget. So it's good to physically have that reminder.
Yeah.
Totally agreed.
Okay, so we've got let's move into part 2 of the CSWA exam, and I'm gonna show you all the important little things that you need to know about
Teach
this.
us your
So
ways.
we did create this part here earlier with these dimensions and so forth, and we
And
talked
just a
about
reminder, up until this point on the other episode. So if you want to catch back up later on, you can go back and watch up to this point.
yep, exactly. So we created that sketch geometry and extruded it, and then we used global variables to change some parameters for step 2 of part number 4. And in between each of these steps, we've been saving it as a different file. That way we can easily kind of get back to it. So for example, here's part 5, or step 5, I guess. So let's continue with this part modeling here. Now, what I like to do, this looks a little bit more complex than what we were doing before, but I'd like to just kind of visually dissect what I'm looking at here. And it's the same component, it's just there's some material that's been removed in a couple different places. So very obviously, there's a new hole here that goes through the whole part. As you can see from this front view, it goes through the whole part. We also have some material removed here and underneath the part here. And then we also have kind of this cutout here that looks a little bit more complex. So I usually like to do these steps in terms of more simple to more complex. So I'll start with this hole that goes through and then cut out this other material and then finally go to that kind of arc cutout shape because I'm maybe not 100% sure like how I would perform that. So this circle is really easy here. We can select this front face and choose to sketch on it. Use my S key to grab the circle tool, and we're done there. Now, new to SolidWorks is we can just simply select geometry or sketch entities, and we can add dimensions to them. So that's 11 there. I can select this circle, control select this edge, and there we go. That's not working. That's okay. So I will just use my mouse gestures to get my dimension tool out and then dimension this as we see on the screen. So there we go. That's a fully defined sketch. That's what we want every time. And of course, we can go to features and extruded cut, or if you have it on your S key, you can do that. If you don't have it on your S key, you can search for cut. You can even add it here if that's something that you do a lot. And I say, we'll go ahead and do that. Now, in this case, we're going to do through all. So I'll just use my right mouse button and do through all, and we can confirm that. So that was pretty simple. Now, the next cutouts are going to be these rectangular cutouts here and here. Now, this has a depth of 19 millimeters, and this one also has a depth of 19 millimeters. So actually, these two could probably be in the same feature if I wanted them to be. So really, I'm looking to cut out this area here and this area here to a depth of 19. So let's try to make that in one sketch. You don't have to. If you wanted to make it 2 sketches, that's fine. But I think I'll just start with kind of a vertical line and click and drag a horizontal line. Now I want to cut out the material of the shape of the part. I could just close this rectangle out, but we could also select this face and we can convert the edges into our sketch if we want. And that'll be a little bit more precise and it'll probably act a little bit better for us in the future. We can also trim out any kind of entities that we don't need, like these back entities here and these here, and trim off these excess edges. And now we have our blue profile showed up here that we can use to create a cut. However, my sketch is not fully defined, so I shouldn't get too hasty. I need to make sure that everything is defined properly. So for example, this line here, it's fully defined, but I didn't add a dimension to it. And the reason is because it's coincident with this edge here, because that's where I created it from, and it did an automatic relation. So be careful about your automatic relations. This is where like practicing a lot in SolidWorks comes in handy, because you'll know why this is defined when I didn't specifically add any kind of definition there. So let's just use the dimension tool to see, is that actually 19 from that face? And it is. So that's great there. This vertical line needs to be 52 millimeters from this edge. And now I have a fully defined sketch. I
Yeah,
use my
that's a great point. Just to, sorry to interrupt you there, but
yeah,
sometimes the diagrams you have to imply a little bit too, right? Is that line actually collinear? Well, let me check the dimension and make sure it is where it's supposed to be. So definitely good to kind of look at those two different ways just to make sure you're actually getting what the print says you're supposed to be making.
absolutely. Yeah, definitely want to validate those things. So let's go to our cut. Now, if I do a cut here, let's say cut depth of blind 19, that's going to cut this portion of the part. So really what I want to do is I want to flip the side to cut and confirm that. Oh, okay. And you will get this sometimes. Let me just show you what that error message is here. It contains more than one open contour. So that's okay. Let's go back into the sketch. I'll go normal too. Let me just kind of see what's going on here. I see there's a bit of an edge here, and this came from the convert entities. So sometimes you want to make sure you get rid of any kind of excess stuff like that. So again, this is again where doing a lot of practice in SolidWorks is going to really help out a lot. So
And check sketch for feature can also be a good one if you're in a time crunch like you would be in this case. Sometimes just visually looking around might be a little tricky, right? So there's always that
yeah,
check sketch for feature tool that might get you to an answer more quickly.
very true. Yeah. So now if we cut this, it's going to cut this material. I don't want to do that. I actually want to flip the side to cut. It's going to remove these bits of material there like that. So that looks pretty good. If I go back to my isometric view, again, kind of like what I uh, was saying last time we had this, go to that isometric view and just kind of check it against the isometric view and the tester client and make sure that it looks roughly the same, just as a gut check. Now I have one more feature to do here. It's this cutout. And we can see that I have a section view here showing me where this cutout is. So this is an arc with a radius of 41, and it's got some other geometry here. Now, the challenging part of this is that it's not centered on the part. So it's actually 12 millimeters from this back face and 24 in depth. So I like to usually set up my sketches so that they, respect the dimensions that are on the document. So the way that I'm going to do that is I'm going to start by sketching on the front plane, and I'll show you where we go from here in just a moment. But I'll do a quick circle, something like this. And again, we can use our convert entities here to grab the outside edges of this and then just trim out any excess that we don't need. There we go. And then we'll trim out this. So now I have this arc shape with my edges, and that looks pretty good. However, I do still need to dimension this. So let's dimension that. That's 41, but it's still underdefined. The center point of the arc is not defined. So I need to define that. Where do I define it? Let's take a look at this view here. We can see that the center point of that arc is coincident with this edge. So let's select that center point, control select the vertical edge, and we'll make those coincident. We can see that this point of the arc is 36 millimeters from the top face. So let's use our smart dimension tool, select that there, and 36. So that is now fully defined. And when we go to create that cut, we can flip the direction and we can specify this as 26, 24, okay? But it's going to start from this face and cut in 24 millimeters. And that's not what I want. I want an offset of 12, then the 24 cut. So what I'm going to use is this from box. And you may not have even noticed this here, but you can specify where you want that sketch to start cutting from. So I'll do the offset. I'll specify an offset of 12. And now we can see that I'm getting the correct geometry there.
Love that tip. That's such a good one. That is a very underutilized section of that dialog box.
Yeah, that can really come in handy sometimes. If you didn't have that, you would have to create another plane and inset that 12, and it would just kind of take you more time. So doing it inside the feature like that saves a couple clicks there.
Love that.
Okay, so I forgot to actually read what it wanted us to do here. So we're supposed to be in millimeter gram second. We'll just double check that. Perfect. We're going to use the AISI 1020 steel, which we have here. Again, we can check the mass density here against the document, make sure that's good. Of course, we have to save it, Control S. And then we want to use these dimensions here. Now, remember, we set up the equations so we can manage those equations and we can easily change those dimensions. So this is 86. And then I'll use my tab key on my keyboard to go to the next one, 58, and next one, 44. Now in this dialog, you do have an automatic rebuild option, or you can just rebuild manually, and you'll see the geometry update in the background. Let's save one more time. And it's going to ask us, what is the mass of the overall part in grams? Again, I like to have my mass properties here on my shortcut key. And then I've got 628.18. And again, the solutions are at the bottom of this document. So you can kind of scroll down there and verify and validate that that's correct. You can also get to mass properties through the Evaluate tab.
Yeah, that alone is a great tip, just adding mass properties right to your shortcut key, because you're going to be using that a lot throughout the whole exam, right? So to have to, even if you're using your scroll on your mouse to go across your command manager to get back and forth, there's no need for it. It's the only thing you're going to be grabbing there often on Evaluate. So just be able to get it right from there. It will actually add up to quite a bit of time.
That's right. Okay, last section here. Now, what I want to do is a quick save as, and I'm going to save this as number 6 before I move on to the next stage here. I'm going to use these images for step 6. So again, the same unit, same material. We're just going to use these images here to add a pocket to the document, and assume all specified dimensions are the same as the previous question, number 5. So we don't have to change any more dimensions here. We simply need to add this pocket. Now you might think that this makes sense for the shell command. So if we do a shell at 1 millimeter, it looks pretty close. However, if we do this section view here, I'll select this top face, do a quick section view, you'll notice that the shell goes through the whole part. And that's not what we're seeing here. We have actually solid geometry here. So that is not correct. So I'm going to Control Z to get rid of that shell. So we have to actually do this kind of manually. It's got a 1 millimeter thickness here. So let's sketch on this plane. While that face is still selected, believe it or not, I'm going to use not convert entities, but offset entities this time.
+1.
So, yeah. So we'll do a 1 millimeter offset and reverse that to the inside. And that's just going to offset my edges into the inside. And now I can do my cut. And that cut is going to be some depth into this part. Well, if I'm looking here at this wall, that's going to be the same as this wall. So it's a 1 millimeter depth or 1 millimeter thickness. Now I could do the math here. I could measure the width of this area and then subtract 1 from it for my blind. But anytime I'm doing kind of like mental math like that, there may be a better way to capture my design intent in this part a little better. And the way that I would choose to do that is to, instead of using a blind as my end condition, using an offset from surface. So I can specify the surface that I'd like to offset from, which is going to be this here, and then specify that offset amount. That's going to be 1 millimeter, and confirm that. So now I have a pocket that's been cut in there to that depth. So I don't have to do any math at all on that one.
Yeah, and those kind of things will come in absolutely invaluable on exams like this, because you already know things are probably going to change in the next step, right? So anything that you can be linking together is just going to save you time in the long run.
Absolutely. Now, this second one is actually very similar to what we just did. So we have an offset depth amount that we have to specify here. There's a 1 millimeter thickness here as well. So let's again sketch on this face, and I will do offset entities. And oh no, actually, you know what? Let's do a convert entities on this one. What I want to offset is that arc face. So I can select, for example, this edge here and offset that. Let's go back here. We can see that offset of 1 millimeter. And then back to our trim tool. We're going to get rid of these bits, this one and that little guy. And now we just have this region that we're going to cut. And again, we'll use our offset from surface. The surface we'll offset from is the back face. And then that offset amount is 12 millimeters. Okay. Back to an isometric view. It does look very similar to this. Let's take a look at that section view. And that looks really good. We can even view that from the top, compare it to the drawing, and the gut check is there. So, okay. Let me just not press all those weird buttons. Okay, let's cut that again. So that's the cut there. Again, it's asking for the overall mass of the part. Again, all of the solutions are at the bottom of the screen there. So you would just do your mass properties, capture that, and go to the bottom to check to make sure it's correct. And that is the last bit of the part assembly. So we're already way over time, but I do want to go into assembly modeling really quick. Do you think we can do that, Jesse?
Let's do it. I say we
Let's
do
do it. Okay. Okay. So for the assembly modeling portion, what we want to do is use this image here to answer questions 7 and 8. So 7 asks us to build an assembly in SolidWorks, download the attached zip file, and save the contained parts in SolidWorks, create the assembly with respect to the origin as shown in the isometric view. So this is important for calculating the proper center of mass. So with the assembly stuff, we are not using the mass properties to relate or to input the mass of the assembly. We're using the center of mass. This is because the mass of the assembly is just the combination of the masses of the individual components. But the center of mass will actually tell the tester client whether or not you mated all of the parts in the correct place and had all the correct mates. So that's why we're using center of mass now. We have some conditions here. The pins are mated concentric to the chain link holes. There's no clearance. And the pin end faces are coincident to the chain link side faces. We're in millimeter gram second, and we have some angles that we have to add here. So, and we're going to choose from one of these options. So how do we get started? The first thing you want to do with a SOLIDWORKS assembly is choose your initial component. In this case, the initial component is going to be number 1 here, this large pin. The reason I know that is because it's showing the origin here, the Y, Z, and X coordinate right there. So I know that, you know, this pin is the initial component. It could also be this component here, but I'll use the pin. So let's just open that component. So I'll go to my open dialog, and we'll open the long pin. Okay, this is an older file. I'm going to say no to feature recognition, which it did say in the document to just say no to. And we can see that it has the origin there, which is going to actually work out really nicely. Now I'm in a part. What I want to do is create an assembly. So I'll use this drop down to make assembly from part. Choose whichever template you want. And what you want to do here is just hit the green check. That's going to position this component with its origin, as we saw before, mated to the origin of the assembly. And that origin will be in the same line with the X, Y, and Z axes here. This component cannot move, it's fixed, and that's a great place to start. Now remember, we want to do millimeter gram second here, so we'll just double check that our template is using millimeter gram second. And there's no need to be concerned about the mass properties here because we're not inputting the mass into the tester client.
Yeah. And just to reiterate, the reason why you wanted to start with that one is because you get it automatically fixed with the first component that you add to the assembly, right? Drop it on the origin and get that automatic fixture, which of course you can adjust later. But again, see, it just saves you time when you find the right one first.
That's right. It does. Yeah. Now I need to get some of these other components in here. We could use the insert component dialog and browse for those components like the chain link. We can open that and put that in here. But actually my favorite way to do it is just to have, usually I have Windows Explorer open. So I usually just take Windows Explorer and drag and drop components in there like that. So that's another great way to do it as well. Let's zoom out a little bit and let's start mating these components together, just kind of roughly. Now we can use the mate dialog for this. It's convenient. We can select a cylindrical face and a cylindrical face, and it'll automatically resolve those, and we can confirm it here. We can pick a planar face and a planar face, and it will resolve those as coincident. I like this pop-up bar. You can change it to parallel or something else, but a lot of times the one that SOLIDWORKS uses is relatively intelligent, and it's the one that you're expecting. So we can confirm that. Now, this part is still allowed to move and rotate that way, so we do want to kind of lock that down. And we know this is in the X direction based off the document here. So I'll do something. I don't have like a plane necessarily in this part that I can make coincident, or I might have one if I just look. So here's a front plane there, a right plane, and a right plane. So I could expand this flyout feature manager tree, select front plane, and select the front plane of the assembly, and that will line them up. But a much faster way to do this is just to use a a parallel mate with some other planar face. So I know that this face is also parallel with that center plane. So I can select that one and select the front plane of SolidWorks, and it'll automatically choose a parallel mate, for example, here. So let's confirm that. Okay. Now that is one way to mate some of these components together, but another way would be to use the control select method. Have you ever used that before, Jesse? Control
My
select?
favorite. It's the only way I mate in SolidWorks these days.
Yeah, control select is great. So, and it carries over from the things we were doing in sketching and parts and stuff like that. So this is, very, very easy to translate. So select, for example, a cylindrical face, control select another one. And when you let go of control, you'll get the same kind of toolbar here. So I
Same
can
thing
say
you
I
do in
want those to
sketches, right?
be,
You just
mhm. I can say I
sketch
want those to be
direction.
concentric. So I could just select that and it'll solve that for me. Same thing with this planar face, control select this one, and I can make those coincident, for example. There you go.
Yeah, and that's
So
a case where I'd even use like a profile center is one of my favorites. You can use one mate, stick a pin in its place. Of course, there's also the peg and hole too, with the alt drag. Also a couple quick tips for those ones.
yeah, great. Yeah, great. Actually, so let's say we have to do a couple more of these, right? So let's try to see if we can speed up the process a little
Sorry,
bit.
I just stepped on your toes, didn't I?
No, no, that's great. No, this is a great segue into what we're doing here. So, if I want to have another one of these, like another one of these instances of this component, I could go back to insert component and go to browse, but that's the slow way. Let's do it the fast way by holding control down and click dragging to bring in another one. So again, we could do the same sort of thing, control select to make these coincident, select this face, make those coincident, but that is getting a little bit slow. So let's try something a little faster. Control drag for another pin. And now I'm going to use Alt. I'm going to hold the Alt key on my keyboard, click and drag this edge over to this edge, and you'll see that it snaps to that one. I'm going to let go of Control and hit Tab, and that will let me flip it back and forth if I want.
Look
Let
at
go of my mouse button, and now that one is in place.
love that.
Very quick. So I still have some rotation there. So I probably want to create an angle mate here, but I'm going to do all those angle mates kind of at the end. So I just really want to repeat this process a bunch of times. So I can hold this, Alt drag to this edge, let go of Alt, hit Tab, and I can drop that in there. Control drag this one. There we go. Control drag that. Hold Alt, drop it on there, let go of Alt, hit Tab, and it drops in place. Let's do one more of these. Control drag. Alt, drag this edge to that one, let go. Very good. And now the last component is another one of these. So control drag, hold the Alt key down, click drag, let go. Back to my isometric view. It does look very similar to this, but now we're ready to add those angle dimensions real quick.
Yep, and we've also got a comment about copy with mates. I was going to bring that up as well. Another, in this case, we've got the same components being kind of chained together. Could be a good use case for that as well.
Yeah, yeah, absolutely. Yeah, copy with mates would be great. Yeah, that would be an excellent option there too. And I get to that using the S key, copy with mates right there. And it just gives you an option, like let's say this component, you go next, and then you can repeat or add different concentric mates to different things. So great option there as well. Okay, let's add these angle mates. We are way over time. I apologize, but we're going to add these in here. And again, these could be added with the control select method as well. So here you have the angle mate, which is easy to add. Let's find our angles, which this one's going to be 25 degrees. Now this one went kind of crazy, but it's okay. Don't be alarmed. We have some buttons that we can press to kind of manipulate this, because 25 degrees is a little ambiguous. 25 degrees from what? Which sense of the direction is it? Now we have two options here that we can use: flip mate alignment and flip dimension. And so these will adjust the mating until you get to the area that you're looking for. So just keep in mind that you do have some options here as far as where that 25 degrees is being measured from. From here to here, we have another angle mate. That's going to be 125. That one looked correct. Okay. And then from here to here, we have another mate, and that's going to be 130. Okay, that one looks good. Let's go back to our isometric view, compare it to our document, and they look very similar. So I think that's pretty much ready to go. Now we need to find which of these answers is correct. So let's go to our mass properties. And here, we've been looking at the mass so far, but we're not going to do that for assemblies. We're going to look at center of mass here. So center of mass I have is 348, -88, and -91. And we have an option for that right there, number A. Or letter A, excuse me. So I'm very confident that, I set this up correctly and that is the appropriate answer. Now, if we look at the next question, it asks us to modify these dimensions and then give the center of mass the assembly. So we could do a similar thing where we want to adjust this, using equations, for example. That's totally fine. But if we don't have a lot more of these to do, like if this is the last question, then maybe something that makes sense is just to adjust it from the mates folder. And you can see in this mates folder, it collects all the mates from the whole document. So I have all these here, and I could just very easily go into each of these angle mates and make a quick adjustment. So if I want to adjust this to 30 degrees, I can do that. And if I want to adjust this one to 115, that's easy. And I can adjust this one to 135 and make that adjustment. Go back to my mass properties and get my new center of mass. And I can input this into the tester client. So again,
One way that I go about doing something like that too is breadcrumbs are one of my favorite things to use in assemblies, right? So if you select on one of those components, hit the D and the D key on your keyboard, you'll see all of the associated mates that are associated with that part or whatever. So you can kind of zip down to the ones that are applicable to that particular thing quickly too. So this is a fairly simple case. So our mates folder is not that long, but again, time is a factor in these, right? So anything you can do to speed things up could help make
exactly.
difference.
Yeah. Okay. So we went well over time, but we were able to get through the whole CSWA sample exam, show some tips and tricks along the way, and that sort of thing. So I think with that we are good. Let's splash this up here again one more time, just so you can see that. Again, the virtualtester.com is there. If you have questions, you can email us at certification@solidworks.com if you have more questions like that. Let's throw the keys of success up there one more time. But that's pretty much it, I think. So, Jesse, I'm going to be in the news and info community at that post. So if anybody wants to join me there and just ask more questions, I'll be there to kind of talk and hang out. Yeah, great.
Yeah, absolutely. Well, thanks so much. We got some good comments in there. I had to put myself on mute for a second because I was laughing out loud. Mike Sandy said that he loves the coffee with mates so much that if it was edible, he'd eat it for lunch.
Okay.
And we had a few agreements. So there you go. I don't even know how to respond to that, but I had to mute myself for a second.
Awesome.
But yeah, some great tips. All of those time-saving tips, they all add up, and it's one of those things where you just, if you know all of those little things that come together, you can add them all up and really be successful. That being said, Eric had a great comment in the chat as well to use all of your time. Even if you have all of these efficiency tips and you get there quicker than the end, always a good idea to go back and double check or triple check your work just to make sure you didn't miss something, because as Mark, you said, there are always those little gotchas where they know common ways to do it wrong, and then you might end up grabbing the wrong one by making a simple mistake. So always a good idea to be as efficient as you can be, and then use all of your time to make sure you've actually done what you were supposed to do to get to the end of the exam and pass it.
Yeah, man, that's a great tip. Yeah, definitely don't run out of that exam until you're 100% sure that you got everything right. So definitely great tip.
Yeah, definitely. All right. Well, thank you guys so much. Mark, thanks for all the great tips, great information. Thanks for everybody hanging in the chat and hanging out with us today. We will see you in the next episode. And of course, if you got more questions for